For the final video in this section, we are going to look at a little recipe on how to form or how to solve radical equations that look like this. And when you're given a radical equation, it may not be this simple looking, but you need to use algebra and until you can get it into a form that looks like this. X, some number raised to the m over n equals another number. So, m over n is the rational exponent. We'll assume that it's in lowest terms. It's a fraction that's been reduced, and k is just some real number. And the example we'll use in this recipe is right here. So, step number 1. Isolate the term that has the rational exponent in it. So for us, I want to get this all by itself on one side. So let's just add 8 to both sides. If I add 8, I'm going to get x to the 2/3, adding 8 equals 4. That was easy. If there were a coefficient in front of this, like say 3 times x to the 2/3, at this point, this 3, I'd have to divide both sides by 3. I need what's being raised to the 2/3 exponent to be all by itself. And if you have a coefficient of 3 in front of it there, that's not being raised to the exponent. Now, so this is my m over n. Okay, 2 is m, 3 is n. What I need to do is raise both sides to the reciprocal of m over n. So it'd be n over m, like it says right here, n over m, the reciprocal of m over n. So 2/3, I raise it to the 3 over 2. Just like that. Now, there's two cases. There's one special case when the numerator, the m, the top thing right here is even. We have to use a plus or minus on the right-hand side. Okay, so notice here's the two cases. If m is even or if m is odd. These are almost the same, almost identical, except that when m is even, you need a plus or minus here. It's similar to when you have, x squared equals 9. Well, x squared is like 2 over 1, right? 2 is like 2 over 1. The top number is even. Therefore, I need to say x equals plus or minus radical 9. That's just a side note there. So, m is even. m is 2, n is 3. So we're going to use this path here. So we're going to get x because this isolates x. This gets x all by itself. X to the 2/3 and then raised to the 3/2 means you get x to the 1 or just x equals plus or minus 4 to the 3 over 2, which we're going to simplify. I'm going to write this as a radical and see what happens. Plus or minus, write a radical, put 4 in the radical, and then 3 is the exponent, and 2 is the root. So it's just a square root. Equals plus or minus, and what is the square root of 4? Radical 4 is a 2. Raised to the 3rd power. So we get plus or minus 8. Okay. And then you can plug it in as well. I'll leave that for you to do. You can plug in positive 8 and negative 8 and see if they both work. I'll leave the verifying to see to you. All right, then we have two more examples. The first one, 5x to the 3 over 2 minus 25 equals 0. Am I going to have a plus or minus when I solve for x? Am I going to have a plus or minus involved in this one? No, I'm not, because the numerator is odd. In this one, though, x to the 2 over 5, the numerator of the exponent is even. I will have a plus or minus in the answer for this one. All right, so let's add 25 to both sides. 5x to the 3 over 2 equals 25 because I added 25 to both sides. Now we're going to divide both sides by 5 to get the term that's being raised to the exponent all by itself. So that gives us x to the 3 over 2 equals 5. And that tells us that when we raise both sides to the reciprocal of this, 2/3, we get x by itself on the left, and we get 5 to the 2/3 on the right, and there is no simplifying this. If you that is an acceptable final answer. If you wanted to write it using a radical, or if the instructions said leave your answer as a radical, it would be a radical. You'd put 5 underneath, and then you'd have 2 as the exponent, and maybe I'll put it inside this time, get the same result, and it's a cube root. I did that because now we could write it if we wanted to like the cube root of 25. So this solution is one way to write it, this is another way, and this is a third way. All are correct. You'll have to just read the instructions to see if there is a preferred way to write it. All right, our last example. We're going to do similarly. We're going to say 3x to the 2 over 5 is equal to 12. And all I did was add 12 to both sides to isolate this term. And then I'm going to divide both sides by 3. And I will get x to the 2 over 5 equals 12 over 3 is 4. And now, since the numerator of the original term is even, I need to remember I've got to do a plus or minus on the right-hand side. So the reciprocal of 2 over 5 is 5 over 2. 5 over 2. And I need to squeeze the plus or minus in there. And this gives us on the left, x by itself equals plus or minus, let me just write it out again a little more clearly. All right, so let's write this as radicals and see if there's a way that we can simplify it. And I think there is. X is equal to plus or minus. What goes in the radical is the 4 underneath it. And then it's a square root, and it's raised to the 5th power. So that's the square root, and we're raising it to the 5th power. We know the square root of 4. Radical 4 is just 2. And 2 to the 5th power is 2 times 2 times 2 times 2 times 2. 2, 4, 8, 16, 32. Plus or minus 32 is the solution. Again, I'll let you plug it in to verify. And that is the end of our section.